But here's where it gets weird. Mathematically, for this left-right flipping to work, the electron needs a few moving parts. In the standard model, the so-called Dirac electron is actually a tangle of more primitive things, two pairs of virtual Weyl spinners. Dirac used these entangled spinners to help define those left and right-hand states. Mathematically, it's these internal parts that interact with zilch. In a Urantia Book scheme, we'd still build up the electron from these virtual spinning parts, but we'd build these spinners from smaller parts, parts designed and tuned to interact with zilch. And we build these interactive parts from Planck scale things, our huddling ultimatons. We can use the same sort of scheme for all leptons and quarks, and as you might expect, accounting for all these internal spinning parts might even allow us to predict the so-called coupling constants of all standard model particles, which is something that all physicists are very keen to do. So how do we connect all this with real particles that collide? Remember, to make contact with the standard model, all we need is for this huddle of ultimatons to interact with this condensate of weak hypercharge. For argument's sake, let's say these primitive ultimatonic structures exist at, or even define, the so-called Planck scale. Then notice what we have. Something that's Planck-sized and quantized and spinning. Which makes you wonder, is this where Planck's constant comes from? In the standard model, we use Planck's constant to define the unit of angular momentum, one of those parameters we have to put in by hand. But in this ultimatonic scheme, Planck's constant becomes simply a measure of how this primitive spinner spins. So here we are at that extraordinary place where spin gets tangled up with charge, where revelation may be making contact with standard model physics. But the question is, could nature really build standard model matter from such ultimatonic parts? Let's see how this might work. Imagine this basic spinning block to be some photon-like thing, and then imagine a simple cluster of such blocks. Neutrinos are thought to be something like this, a mixture of three primitive spinning things. And what are neutrinos famous for? Interacting with zilch. In fact, zilch, weak hypercharge, is the only thing a neutrino can feel. So picture this as some handed chiral structure in that condensate of zilch. What we have here is a standard model particle interacting with standard model zilch, but built from very non-standard parts. But there's more. As we know, this Higgs-type field is thought of as a space-filling condensate of primordial charge, which sounds a lot like space-filling condensate of primordial charge. In other words, segregata, the very stuff from which these primitive particles are made. So here's that question again. Could a region dense with segregata behave locally like the sort of Higgs-type field our standard model needs? At this point, let's recall why a Higgs-type field was invented: to give a quantum property called mass to standard model particles. Does the Urantia Book say anything about how particles get mass? Yes, it does. In fact, if we think of mass as response to gravity, then these papers describe two very different types of mass a particle can have. The first is an intrinsic property of ultimatons, their so-called absolute response to the source and center of gravity. The second is described as an interactive phenomenon. So, for example, if our building block has 3 ultimatons, and we build a tiny structure from 3 such blocks, then we have 3 times 3, or 9 ultimatons. 9 units of absolute ultimatonic gravitational response. 9 units of absolute ultimatonic mass. But in the Standard Model, this tiny structure with its 9 units of intrinsic absolute mass will be interacting with zilch. It's this interaction that induces a second type of mass, a second type of gravity and response, which the Urantia Book calls linear. From paper 12, section 3, quote, "Linear gravity is an interactive phenomenon." It's precisely this second type of mass, this linear or interactive response, that the Higgs mechanism was invented to explain. To help get a feel for this distinction between 2 very different types of mass, think of a small pond of water. The water in this pond will have a certain well-defined total gravitational mass. Where does this mass come from? It's just the total sum of the mass of each molecule. Here we see these molecules, H2O, in their random fluid state. Now imagine a few of these molecules, as their temperature drops, arranging themselves as crystals of ice. Notice the gravitational mass of the water in the pond hasn't changed. We still have exactly the same number of molecules of H2O. But now we have these crystals of ice with certain properties, properties that make them different from the water in which they float. The Urantia Book scheme for mass is just like this. Imagine a much bigger pond, a superfluid galactic halo of invisible ultimatons swirling in that condensate of charge. Such a pond will have a well-defined total of absolute ultimatonic mass, simply the sum of each ultimaton's tiny bit of this absolute kind of mass. Now, once again, imagine a few of these ultimatons as their temperature drops, arranging themselves as crystals of ice, but this time ultimatonic ice. Once again, this internal arrangement hasn't changed the number of ultimatons, so the absolute gravitational response, or dark mass, of this invisible galactic halo hasn't changed. But these crystals of ultimatons come with, or rather generate, 2 interesting properties. 1, electric charge, and 2, interaction with weak hypercharge, that Higgs-type field in which they float. And so these electronic crystals, in fact all leptons and quarks, end up with their tiny allocation of 2 very different types of mass. 1, an absolute mass from the number of their internal ultimatons, and 2, an interactive mass from their interaction with primordial zilch. This distinction between 2 very different types of mass has surprising implications for black holes and for galaxies, as we'll see in the next 2 sections. So here's what seems to be the Urantia Book story so far. From transcendental force organizers to finite power directors, all the way down to Frandalanks and Chronaldecks embedded in space and time. A condensate of space potency is sequestered and quantized and made to huddle, and then to interact with that same condensate from which it came. The point is, if we're going to build standard model matter from ultimatons, we're going to need building blocks, something like this. Okay, so we have hypothetical building blocks. What about that electron? Paper 42 says electrons are built from 100 ultimatons. How might this work? Well, with our Dirac electron as a tangle of vile spinners, and with these vile spinners built up from interactive neutrino-like parts, and with these interactive parts built up from Planck-scale things, our huddling ultimatons, let's do the math. 3 times 3 times 3 times 4, that's 108. 108 tiny units of absolute gravitational response. Now, if we allow a few of these clusters to share dipoles and tripoles, like atoms in a molecule share electrons, then we can round this down to an even 100. And there we have it, the electron as ultimatonic engineering. Of course, the issue here is that such ultimatonic engineering implies design, which may be something that physics is not yet ready to explore. Nevertheless, does physics have room for a story like this? Think about Dirac's famous 1928 equation for the electron, which we still use today. This equation tells us nothing about what the electron actually is. It simply helps us to predict, with extraordinary precision, certain values that we can expect to measure, which leaves plenty of scope for speculation. The current standard view sees the electron as a so-called point of charge. But this standard view comes with a rule: renormalize, or don't look too close. In this scheme, reality itself gets slippery. The electron becomes a pulse of probabilities somehow entangled with virtual echoes of itself. But what if we do look very, very close? Well, then things get weird. So weird that electrons must be something more than mere fluctuations in a field. One famous alternative is a Planck-scale string tangled up in 10-dimensional space. Of these two currently popular but incompatible schemes, one requires that we complexify reality, the other that we complexify space. The Urantia Book suggests a third possibility: complexify the particle. In this Urantia Book scheme, the electron becomes a truly fabulous Planck-scale machine. Remember how in Paper 101, Section 4, on the limitations of revelation, the author states that, quote, within a few short years, many of our statements regarding the physical sciences will stand in need of revision. Will stand in need of revision. So far, we haven't attempted to revise the Urantia Book story. With regard to the nature of mass and matter, and expressed in modern terms, this, or something like it, is that story. And quite a tale it turns out to be. So much for mass and matter. Let's now think what all this means for dark islands, those so-called black holes in space, and for the Milky Way. First, dark islands.